Hello and welcome to our presentation. This is our Bio 325 presentation of our Unknown Hormone Project. We are the group amino acids because we mean business, and my name is Leah Eversole and this is Caitlin and Adrian, and we plan to share with you what we've been doing in this project so far. Here's our little mitochondria saying we'll be a powerhouse and give you a good presentation. Okay, so let's get started.
Okay, so what do we aim to accomplish? Our objectives for this project were to look at experimental data versus control data, and how does our experimental data differ from control data, and what were our initial ruleouts, and the 3 additional tests that we requested, and we need to see the final diagnosis, our acknowledgements at the end, and to discuss any questions that you have for us. And here's our experimental data versus our control data. And as you could see, there were no significant changes to glands, but there were significant changes to plasma FFA and GTT. Now, what are these values and how do they differ?
All right, so to start off with the definitions of those 2 values, we have our plasma FFA, which is plasma-free fatty acids, which is in micromoles over liters. The normal range is 0.1 to 0.6. Our experimental was 2.27, and then our control was 0.58. And then GTT is glucose tolerance testing. It is in milligrams over deciliters. And the normal value for that is 2.27 compared to 0.58. The normal value for the plasma-free fatty acids is 0.1 to 0.6. And our GTT testing varied for every hour that was tested. So the main differences on our experimental versus our control data, the plasma FFA was significantly higher with 2,270 versus 580. In our GTT, our trends were significantly higher over the 3 hours in our experimental data compared to the control. And then another observation is all of this ties into what we decided to test, because an overactive metabolism would lead to an increased blood sugar and free fatty acid levels. All right, and then just our initial ruleouts, we kind of made a list of all the hormones that were given as options and went from there. So looking at the continuous dose of hormone given, we decided to rule out thyroid stimulating hormone, growth hormone, HCGT, testosterone, estradiol, placebo, and initially we had ruled out epinephrine, thyroxine, a glucocorticoid, ACTH, and somatostatin. But after talking to the professor during our initial consult, we decided to investigate epinephrine as well. So the final 2 hormones we investigated were somatostatin and epinephrine.
Thank you, Caitlin. So going on from there, we are looking at our 3 additional tests that we requested. Our code number is 455 for this project. So the 3 tests that we looked at were vital signs, behavior and appearance, an RIA of somatostatin in blood plasma, and a metabolite test for catecholamines and VMA in the urine. And all of these tests were processed for both our experimental and control rat cohorts. For the vital signs, behavior, and appearance, in our experimental data, the heart rate, respiration, body temperature, and blood pressure were all significantly higher than compared to the control. And for observational data that the technicians recorded for us, they found that the pupils were dilated and somewhat reactive. The behavior was reduced sleep, increased movement, and searching behavior. Aggression levels were greater than the control group. So this might lead to us believing that it is epinephrine compared to somatostatin, because this ties into the fight or flight response, something that might occur during that response. And our next test that we did was an IRA of somatostatin in blood plasma, and we actually found out that this was inconclusive and actually not a test that we really needed to request. There's the values presented for you, but we probably should have gone with a tropic hormone like higher up on the cascade to test for somatostatin, but we have some reasonings why we might be able to refute that it is somatostatin, and I can go over that with you now. So our reasoning is an increased level of somatostatin due to it being injected into the rats would inhibit the tropic hormone, thyroid stimulating hormone. A lower level of thyroid stimulating hormone would lead to the pathology hypothyroidism or hyperthyroidism, kind of all loops together. Because the thyroid is not being stimulated to make thyroid hormone, lower levels of thyroid hormone in the blood would then stimulate the hypothalamus and then the adenohypophysis to produce much TSH, which would eventually overstimulate the thyroid gland and cause a goiter, also known as an increased mass of the gland, to form. There is not a substantial increase or decrease in mass of the thyroid gland in our experimental data as compared to our control data. And we also didn't see any difference in growth hormone evidence, which is also tied into somatostatin. So this is why we are refuting somatostatin. And moving on to our final test that we decided to ask for considering this is metabolite test for catecholamines and VMA in the urine. Now these are the broken down metabolites that would be if epinephrine was given. And you can see in our experimental data it is much greater than in the control data, which is also another piece of evidence to lead towards epinephrine. Therefore, we decided our final diagnosis is epinephrine for our project. We think this is what the rats were given compared to the control. And yes, we'd like to thank our lab technician for promptly processing our request, and thank Dr. Go for guiding us through our process of elimination. And thank you to the viewers watching this. We hope you enjoy it, and we look forward to answering any of the questions you might have. Let's get us all back on here. So yeah, thanks, and we will see you later. Bye for now.